Hi, this is Math 1, Unit 1, Lesson 3, looking at some homework help solutions for Form K, if you work on this form in your class. And I'm going to work through some of the things here just so you are on the right page and know you're doing the right stuff. So we're looking at solving equations of variables on both sides. So to do this, we're going to take a little pointer from last lesson where we combine our like terms and regroup things so that it works out okay. So first of all, I'm going to do is I'm going to begin by moving the 4p to the other side by subtracting 4p from both sides. So 5p minus 4p is a p. Then I'm going to subtract 6 from both sides. So that goes away there, and I'm left with negative 8 minus 6 becomes a negative 14. So I have p equal to negative 14 for my first solution on that problem there. Okay, moving down to number 3. Again, same thing. Let's move some things around. I'm going to subtract a k from this side, subtract a k from that side. All right, there's no number in front, but it's implied that there's a 1 there. So really it's a 1k. So 13 minus 1 is 12k. And then for the whole number, I'll subtract 5 from this side and subtract 5 from this side. So 7 minus 5, or sorry, I could do this. The signs are the same. I find the sum and keep the sign the same. So 7 and 5 become 12, and a negative minus a negative is still a negative. So now I have 12k equals negative 12, so I will divide both sides by 12. And that means on this side I'm left with just the k, and that's equal to 12 divided by 12 is 1, and it still stays a negative because a negative divided by a positive is still a negative. So k equals negative 1. On number 6, the next one here, I'm going to go ahead and let's do this. I don't like the negative there, so I'm going to add a 2m to this side and add a 2m to this side to make that go away. So on this side I have now 4m. Now let's move the whole number over. We will add 3 to this side and add 3 to this side. So this becomes 16 equals 4m. I'm going to divide both sides by 4 to get the m in isolation. 16 divided by 4 is 4, and so m equals 4 for number 6. Let's look at number 7. Number 7 is a good problem, and it kind of drove me nuts a little bit, quite honestly. I was able to do the first part, so I'll show you how that works, but the solution that I found was different from what the answer key showed on my answer key. So I'm not sure if I'm right or wrong. I did it a couple times, and I still keep coming up with the same answer, so I'll leave it like that, and then you can kind of argue with the answer key about it on your own. It says Suzanne is going to rent a car while she's out of town. One car rental company offers a flat rate of $35 per day.
This is Sharon.
So that would be $35, the first one, times the number of days, plus 10 cents per mile. So we'll do 0.10 times how many miles they go. Okay, that's car company 1. Now another car company offers the same car for $25 a day, right? So $25 for each day. And I don't need to put the dollar sign, but I could. $25 a day plus, there's my plus, 25 cents, 0.25 for each mile. She will need the car for 5 days. How many miles will she need to drive for the first rental company to be a better deal? Okay, so our two equations look something like this to begin with. However, to write the equation down, we would say it's 35 times 5, since we know it's going to be 5 days, plus 0.10 m. And then I have over here 25 times 5 plus 0.25 m. Now I'm going to set them equal to each other because what that would look like on a graph, for example, is let's say that this was like $10, $20, $30, $35, $40, right? 30, and I'm making this up. This is an estimate here. 10, 20, 30. Like the first car company, it's like the further I go, I start at $35, but I'm going to pay 10 more cents every mile. So I might have a graph that looks something like that. Okay, this is car company number 1. Car company number 2, though, starts at 25, but because I do 25 cents a mile, it starts to go up a little bit steeper, right? So they're still both linear. At some point here, it's going to cost more for company 2 than it will for company 1. Company 1 starts off costing more, but at a certain mileage point down here, that's what we're trying to find out, number 2 costs more. So the question is, how many miles would you need to drive for the first rental company to be a better deal? So at what point does this line become less than that line for my cost? Because this is my cost, and this is my miles. That's what they're asking you to do. So to do that, you actually will set the two equal to each other to find out where is that point going to be. And when you do the work here, you have 35 times 5, and 35 times 5 is 175. Let's see, I'm going to write down, let's see, I'll do it here. So this becomes 175 plus 0.10 m equals 25 times 5 is 125 plus 0.25 m. And now I'm looking at the types of equations that I was doing up before. So I'll subtract 125 from this side and that side. That goes away, so I have 50 on this side. I'll subtract the 0.10 m over here and subtract the 0.10 m over here. And that's going to give me 50. We have 0.25 we're subtracting, right? So this is going to be 0.15 m. Okay. And let's see here. Then the next thing to do is divide both sides by 0.15. 0.15. So I have 50 divided by 0.15. And my calculator then tells me that I have 333.3 repeating equals m. And what's funny here is I'm talking out loud. Of course, when you do this on video, you can't do much about it. Is that's actually the solution the book got as well. I finally got the right answer. I found my own mistake. I was actually on accident doing quick mental math, and I did a plus right there on my initial times through each time. And so I was dividing by 0.35. Oops, my mistake. That is the correct answer, and that's what the answer key says as well. So that's the equation is here, and the answer is there. That is actually right. Huh. Good thing I checked my work. Nice job. All right, let's look down below. Number 10, solve each equation, check your answer. So to do this here, I'm going to distribute the -1, distribute the 6. So this becomes rewritten as -3b plus 15 because I put the negative with there, and negative times negative makes a positive. I'll distribute here, and I have 12b plus 30. And now I'm going to move some things around. Let's add 3b to here, add 3b to there for a 15b. And then let's subtract 30, subtract 30. So I have a -15 equals 15b. Divide both sides by 15. And I have -1 equals b for number 10. On number 11, again, combine my like terms. I can put those together first. And I could say, well, that's 8x plus 7 equals -8 plus 3x. I can move my I can move 3 over there, so let's subtract 3x, subtract 3x. That becomes 5x. I can also subtract 7, and that becomes over here equal to -15. Again, the signs are the same, so I find the sum and keep the sign the same. So 8 plus 7 is 15, and still negative. So I'm at 5x equals -15. I divide both sides by 5, and x equals 15 divided by 5 is 3, and it's still negative for number 11. All right, let's turn over the back side and look at a couple more. The next questions want you to solve each equation. It says, if the equation is identity, write identity. So identity means that it's actually just equal to itself. The two sides are equal to each other. Okay? That's going to be identity. If there's no solution, which means it doesn't equal anything, we'd write no solution. Doesn't work out there very well. And if there is a solution, we're going to find out what the value is, and that'll be some sort of number. Okay, so let's take a look at a couple. This first one here, 13, we're going to distribute, and we have 24z plus 12 equals, distribute here, 3 times 8 is 24z plus 3 times 4 is 12. So what I notice is that 24 plus 12 equals 24z plus 12. It's the same, it works out, it's identity. They equal each other, so we would say this is an identity solution. Because if I was to subtract 24z, that becomes nothing on both sides. And I subtract 12, I end up with 0 equals 0. So this is what we call an identity. Okay, the two sides equal each other. It's an identity equation. Okay, so our actual answer is identity, sorry. Number 16. All right, we have -5x, distribute, minus 35 equals -5x and plus 35. So in this case here, what happens is if I do the work, I add 5x to this side, on both sides, right? That goes away. I'm left with 0x. Now I add 35 over here. Add 35. 0x equals 70. Well, 0x is actually 0, right? Does 0 equal 70? Nope, it does not. So this is going to be one where there is no solution. Because 0 cannot equal 70, it doesn't work. That's a no solution one. Let's look at number 20. For number 20, I have fractions here. All right, not a big deal. Let's move some things around. Let's go ahead and take this minus 2/3 h and let's add it to this side. So 2/3 plus 2/3. Well, same denominator, so I can add the numerator. So that actually becomes rewritten as 4/3 h. Okay, we good there? So when I move that over to there, 2/3 plus 2/3 is 4/3. And now let's move the negative 9 over here. So subtract 9, or sorry, add 9. Add 9, add 9. So that goes away. So 6 plus 9 equals 15. Now I'm not done yet. To get rid of the 4/3 from this side, to put it over there, I'll multiply by the reciprocal on both sides, because that'll reduce to 1, 1, 1, 1. So I'm left with just the h over here. So h is equal to 15 times 3, which is 45, divided by 4. And I'll leave it like that, and that's my solution. So h equals 45/4. Okay, and let's look at one last one here, number 22. We're going to write down the equation. 6 times the sum of a number and 3. Okay, when they give you this, first of all, 6 times, that's 1 bit, but the sum of a number and 3. That means this has to be done before I can do the 6 times. Sum means to add, so we're going to say a number and 3, that's my sum. So this is 6 times the sum of a number and 3 is the nice word that means, equals, is 12 less than 12 times the number. Okay, so this is going to be 12 less than 12 times the number. Well, how are we going to do that one there? What does that exactly mean? 12 less than 12 times the number? Starting to get a little confused, right? Well, with the subtraction part, when you have a less than, I'm going to start with 12 times the number first, actually, and work backwards. I got to do a little flip-flopping here. Think of it this way. I have to know what 12 times the number is, and then I need to find out what 12 less than it is. So I have to put the 12 less afterwards. If you thought about it this way, you really could write it out left to right. If you wrote down 12 less as being a negative 12 plus 12 times the number in. Because if I did that, there's no difference. I just changed the order around, right? So that actually would work, because then if I flip-flop that around and change things, I put the 12 in the front and the negative there, and it works the same. So I could write 12 less as 12, negative 12, then 12 times the number, and we're okay. That's the equation, how you'd work that out. Then it says, write and solve. So let's solve it here. 6 times n is 6 in plus 18 equals 12 in minus 12. I'm going to go ahead and let's subtract 6 in here, subtract 6 in there. So I have 6 in on this side, and let's add 12, and we have now 30 in. So 30 equals 6 in, divide both sides by 6, and n is going to be equal to 30 divided by 6 is 5. And so that's my little solution there, and we're all done. Hope that helps you out with your homework a little bit. Good luck on the rest of your problems.